Good morning, everyone. I welcome you all to today's webinar. My name is Eugenia Emmanuel, and I'm a technical sales staff. This is going to be an insightful webinar, and I really want to appreciate you for being with us all through the month of January down to the month of May. This webinar will be talking about leveraging GIS and 3D modeling for flood preparedness and early warning. So I want you to sit back, sit tight, and just know that you're going to enjoy this session. Hi, Mr. Jibril.
Hi, Eugenia. Good morning, everyone. Thank
Hi,
you for
Mr.
having me.
Jibril.
Eugenia, can you hear me?
Can you hear me?
Yes, I can.
Okay, so I think over to you. The floor is yours.
All right. Thank you very much, Eugenia. Thank you, everyone. Welcome to the Sambus Geospatial webinar. My name is Salah Jubril Larotimi. I'm the professional service lead, as she mentioned earlier. So we'll dive right into our webinar. Eugenia, please confirm that you can see my screen, please. Sorry?
I can see your screen, sir.
Okay, all right, thank you very much. So welcome to our webinar, which is leveraging GIS and 3D modeling for flood preparedness and early warning. So as she has rightly introduced us, spoken about flood. Sorry, just give me a minute. Okay, thank you. So to carry out flood impact analysis, you need certain data sets and you need certain softwares for you to be able to do that. So some of these data sets include which is not limited to satellite imagery, data elevation model, as well as water spread area, as well as building footprint. So for this particular webinar, we would be using the ArcGIS Pro, which is part of a software under the S3 suite. We'll use this to carry out flood impact analysis for us to see the areas that this can be done either pre or post. But for this particular one, we're doing a pre, so as to see the buildings or properties that would be affected by flood. Our region of interest or area of study is Makurdi in Benue State, Nigeria. So for this particular webinar, we made use of SRTM, which is short radar topographic mission. That's where we got the data elevation model. This was used to derive elevation, slope, flow direction, as well as flow accumulation. While for the satellite imagery, we actually used the Sentinel-2. So this was used to extract the land use, land cover. So now move to the ArcGIS Pro. Now, immediately you open up the ArcGIS Pro, you have you're able to load your base map. As well, you can import administrative shapefile, so as to be able to, for instance, in Nigeria, we have states, local government, world. For this particular one, we're using the Makurdi in Benue State, which is a Makurdi local government for this particular analysis or this webinar. So the first thing is to get your DEM of your study area or region of interest. For this particular one, we go for Makurdi, which we got from the short radar topographic mission. So here is the DEM for Makurdi in Benue. So after getting the DEM, the first thing you would do, or the next thing you would do, is to now get a slope map of Makurdi in Benue State. So for this, you have numerous options to be able to do this, which has been made quite easy on the ArcGIS Pro. So when you come to imagery, you could click on raster functions. When you click on it, so you have these tools that are available for you. So literally what this does is it has made your work easy for you to be able to generate or create layers that are actually stored in memory. So you don't actually need to store this data on your storage on your hard drive. So this reduces how do I want to put it, like for it reduces you using the space up on your physical drive. So let's say, for instance, you want to actually generate for slope. So the first thing is you come to surface and you have slope here. So it's for you to click on it, select your DEM, which is Macaulay that we rightly done, and then you can then run it. But another option from this is to come to your geoprocessing toolbox, and you can search for slope. So when you search for slope, you will use a spatial analyst. So after you've done this, so you input your raster, which is the DEM of your region of interest, and then you set an output for your raster data. So, and then you can run. So you have this available at any point in time, and then you can go back to this, or you can even export this data to be able to carry out any other further analysis, or you even want to just visualize. So after doing that, the next thing is for you to get the Sentinel-2 image of your study area. After getting, so here is a Sentinel-2 imagery of the study area. Though this has been clipped to the study of interest. So when you want to do this, you can come to the geoprocessing toolbox, and then you can search for clip raster. So you can either clip raster, or you can actually extract it by mask. So the tool literally does the same thing, but on most occasions it's preferable you use extract by mask. So when you do that, after you've extracted like this, you have two options now to go further. For you to do your land use land cover analysis, you have the option of either doing supervised classification or unsupervised classification. When you want to do your supervised classification, you need to get ground control points. This can be done when you carry out your reconnaissance survey. So as it is said, the more the merrier. The more you get ground control points, the better for the output of your result. While for the unsupervised classification, you can either classify based on the object, or you can use pixel. So what this does is it's going to you give it a group, the number of group that you want, then it would allow you to be able to when you group based on pixel, it's going to group it based on pixel, based on the electromagnetic spectrum, where from a particular micrometer to another one, and then you see objects in that fall within that range. So I've opened up the image classification wizard. So here, this is where you select either you want to run a supervised or an unsupervised classification, and then you can run it object based or cell based. So after doing that, you get a result of your land use land cover. So for this particular one, supervised classification was actually done with this. Now, the next thing is for you to generate a layer for waterway. So for this, for the Sentinel-2 that was actually used for this, the date you'd select is actually determines the cloud cover. So for this one, it was actually gotten during the dry season. That's why you can see the boundary for the waterway has actually shrunk a tiny bit. So you could as well get an image of during the raining season, though the challenge for the raining season most times is always the cloud cover. So when you download an image with lesser cloud cover, it reduces the the rate of preprocessing that you're actually going to do, so as for you to be able to remove those cloud covers. So for this particular one, you would see that the waterway here is a bit expanded more than what is actually on the Sentinel-2, because this was actually digitized out of an imagery that was gotten during the raining season. So the next thing to do would be to now fill the EM of your study area. So what this does is it removes depression or sink in the DEM that will disrupt flow modeling. So the scientific rationale behind this is that natural or erroneous depression, which can trap water in model, often leads to inaccurate flow direction and flow accumulation. So when you fill, it ensures continuous flow path across the terrain. So after you've done that, when here is the tool. As I said earlier, when you come to hydrology, you can use this to fill, which automatically creates a layer, or you can come to the geoprocessing toolbox and just search for fill. So here is it. So you can either do this, as you can see, it is as well under the hydrology toolbox here. So the next thing is for you to fill. So the next process is for you to now generate flow direction. So flow direction is done to determine the direction water will flow for each of the cell in the region of interest. So for this particular one, when you click on the flow direction tool, you're going to use the D8 algorithm. So this step would actually ensures that the flow directions are based on the steepest descent, forming the basis for identifying the drainage pattern. After you've done that, the next step would be to generate flow accumulation for your study of interest. So this is done to calculate the amount of water accumulating in each cell, which it helps identify potential stream channel and area of high runoff accumulation. So this aids in flow dynamics as well, which the tool is available, which is what I'm hovering over presently. It's just for you to double click on it, and then you input your raster image and then where you would want the output to be. After doing that, the next thing is to now go to your raster calculator, which you can actually search on the geoprocessing toolbox. So here is the raster calculator. So for you to actually generate it, you would actually input there's a formula to this, which is you input log 10, which you can search on tools here when you scroll down. So this is log 10, and then you input the flow accumulation into So after you do this, then you select where you would want the output to be saved, and then you can click run. So for the log 10, it is done to normalize flow accumulation value. The scientific rationale behind this is that when you apply this, it actually helps transform, which reduces the skewness of the flow accumulation, the accumulation data, which better helps visualize and show the threshold setting for stream network extraction. So the next step from this would be for you to now condition the tool. So when you do this, hold on, please let me check. So this helps condition the tool so as to bring out or like generate the flow accumulation in a better light, just for you to see where the waters are actually accumulated the most in your study of in your study area or region of interest. So the next thing to do would be to now generate your stream order. So you can come, you would still come again to the geoprocessing tool, and then you could type stream order. When you click on it, so the next thing would be for you to now input your raster layer, which is the condition, and then you input as well the flow direction raster image or layer. So here's the flow direction, and then you set an output for it. which uses the strialar method. This helps to assign orders to stream, helping to identify the main channels versus the attribute. It's vital to it helps to understand flood propagation path. So when you do that, you get an output like this. So this stream order is actually conditioned based on the branches or how the elevation of the study area is. So for Makurdi in Benue State, it actually generates from stream 1 to 6. So when you do this, you can actually even view the attribute table so as for you to be able to see the count. So majorly what this means is the main body, or like the main part where the water passes through, is the stream order 6, while 5 is connected to it, 4 is lesser, which is connected to it, 3 is lesser, which is connected to 4, 2 is lesser, which is connected to 3, while 1 is the lowest or the smallest or the shortest. So when you zoom in, for instance, when you come here, where you can see presently, this is stream order 1, as you can see. So it feeds stream order 2, while 2 will feed stream order for this particular one I'm showing. So as you can see, the green color is stream order 3, while the 3 now you can see, connects to 5 here. And when you trace, so this is 6 here, which is actually the major river part, or the pathway in which water actually flows through in the study area. So moving on, the next thing is you can actually convert this stream to features. So you just come to the geoprocessing tool. So as you rightly have it here, which is stream to feature. So it's just for you to click on it. So majorly what this does is it converts your raster to vector. So after you've converted it, it helps you to, when you open up the attribute table, you can actually add a field to it for you to be able to calculate the length of each of these features. So the next step to this would be to buffer the waterway. So we have the buffering tool, which is available here. So after you will input the waterway that was digitized, which I showed earlier. This right here, the waterway here. So you input it as your input feature, and then you set your output class as well. You can actually determine the units that you would want to use. It might be in kilometer, in meters, in decimeter, and every this thing that you have available here, and then you input your value. So for this, we used 50 meter. The idea behind this is, as you rightly know, let's say when there is high rainfall, or let's say for instance the Lago Dam in Cameroon is actually opened up, most definitely the river would actually overflow its banks. So that's the reason why we buffer, which is the reason why when you want to build your house or your home or your property, a particular distance is actually set from the waterway for you to be able to construct, so as whenever the waterway actually overflows its banks, it won't affect your property. So here is the result of the buffering analysis that was actually carried out. So the next stage to this would be to now reclass each of the data sets. So what you need to do is just to come to class. So you would reclassify. So the next, when you click on reclassify, you select the feature layer that you would want to reclassify. So let's say I'm just we'll use the first one is to use slope. So for this, we'll reclassify it into 5 classes. We'll classify into 5 classes. So here is the result. So it has generated its slope, and this is the result. Same thing you would do for the land use land cover, as well as the stream, as well as the waterway. So the idea behind this is this. For instance, when you're using the slope, so for where I'm zooming in presently, where you have this should I say green color, it's so for areas that are close to the waterway or that has more depth, you would classify these areas as areas that are likely prone to flood or highly prone to flood. So same thing when you want to do for land use land cover. Same thing for land use land cover. You would choose the waterway would be like the major areas that would be prone to flood. So you can actually assign this from either, let's say, from 1 to 5 as the classes that fall within that fall within the classes of 1 are the areas that are majorly or highly prone to flood. While the built up will come next, as well as the airland, while vegetation will last. As you rightly know, vegetation serves as a drag when there's flood, or like when there's an inflow of water into when there's flow of water into the in the study area or region of interest. So you do the same for as I said earlier, you do the same for stream as well as waterway. So after that, the next thing you need to do is to now come to geoprocessing, and then sorry. So the next thing is for you to now search for weighted sum. So it's a tool. You have it right here, which you can presently see on the geoprocessing toolbox. So what you need to do here is for each of the classes that you've reclassified, you would give them a value. You would choose a field that you want to use to be able to identify. So let's say, for instance, when you come to land use land cover here, it's advisable that you can either use value or count. So this would actually, but earlier on what we used was value. That's when we were reclassifying. So when you use value here, it helps, or it recognizes or understands, as you can see, waterway is 5, bare land is 4, built up is 3, while vegetation is 1. So that means areas where areas that are well vegetated are less prone to being affected by flood or being flooded. So the next thing is for you to now weigh each of its feature layers that has actually been classified, from waterway to the stream to the land use land cover, as well as slope. So you, based on expert knowledge, you would assign a weight to each of these, which after doing it, or after doing that, you would get a result that's showing your flood susceptibility map. So here you have it, and then the result would come out, and then you'd be the one to actually add. So the idea behind this is going to give you the OID, the value, and as well as the count. You would be the one to actually create a field for flood risk level. So you would be the one to input it based on what you intend to assign to each class. This came out with 5 classes. You could do it, it could come out depending on your result could come out in, let's say, maybe 3 classes, which is going to be low, moderate, or high. Or you could as well even reclass this so as to merge, whereby maybe you only just want 2 classes as maybe just high and low. Or you could even merge it into, as I said, 3 classes 4, 5, or even more. So here you have your result here. So the next thing, if you want to, you can decide to go further, and then you would convert your the result you get from your weighted sum. You can convert it from so it comes out in raster. You can convert it to vector, and then you can add a class which you can use to calculate the areas or know the extent of areas that are actually prone to flood, which you have here for each of the class. As well, you could go further in your analysis on the ArcGIS Pro for after you based on the land use and cover that we've generated earlier. You could as well convert it by using raster to polygon. So after you generated that as well, you could calculate the extent of each of the classes on the land use land cover, which you can see presently on my screen. So the next thing is you could come to the geoprocessing tool and search for a tool which is intersect. And then you can actually intersect the two layers. That's the flood prone area as well as the land use land cover. So when you do this, this is the result you would get. So you would see for each of the classes which areas are actually or the extent at which each of these areas are actually prone to flood, which you can see on the flood risk map here. So you know, based on built up vegetation, bare land, water, built up vegetation, for each, these are the major classes which are the risk level. So you know, for the very low class or areas that are very low to flood, you would see at the extent at which water, bare land, vegetation, and built up are actually prone to flood. So the next thing we'll be moving down to. So after you've done this, you could create a layout for each of this, and then you could export this and add it to let's say maybe your project, your report. So you have it here. So you can either when you want to do this, you could click on share. You can copy to clipboard and then paste it on your Microsoft Word or PowerPoint or any other program that you're actually using. Or you could export the layer. You could export it as a TIFF or any other format here, PDF, PNG, and then you would select the location where you want to save it. You can clip it to the graphic extent. So what that means is what you can presently see on your screen, you can actually clip it to that extent. You can compress the image or not, reduce quality, as well as set the resolution, and then you can export your result, and then you can save this as a preset, so you can use it subsequently for other results that you would want to save. So the next thing is for you to you could convert to global or local scene, and then you would have, but you have this result. But before coming here, the next thing or what was done was for the areas that are very high or highly prone to flood, you have two options. You could either get a satellite imagery with a very high resolution, or what Esri has done now on the base map, you could load an hybrid image. The base map has numerous options, from imagery, hybrid, street, navigation, topography, even open street map. You could add it to your result. They are all readily available. So when you add the hybrid imagery, so it's presently updating the base map. from the result when you come here. For instance, for
Okay, don't go.
Right. So here you could use, for instance, the grid code, and then so the idea behind this is you could follow each of the class so as for you to see the demarcation, to see the buildings that are highly prone to flood in the study area. So what this does is this. It allows you, though there are model where you input your satellite imagery that you've gotten, and then it's going to generate footprints for each of these buildings, or you could actually digitize each of these buildings from your base map. So what you have a result that you could actually convert to a 3D model. So when you convert this to a 3D model, going further in your analysis, what Esri has done is they allow you to be able to simulate rainfall. So when you want to simulate rainfall, when you get to your global scene, which we've converted the buildings that are highly prone to flood within Makurdi, you could enter the duration for the rainfall as well as the rates of rainfall in inch, in millimeter. You would choose as well. You could set the evaporation rate for your study area. After you've done that, then you can click run. So for this, we've set that for 1 hour 30 minutes, rain that would be dropping would be 800 millimeter. So it's going to capture the elevation value at first, using the topography of the area. So it's this is the result you would have seen seeing it as rain is falling in the study area, and how each of the buildings, how they would get flooded. Though the idea behind this, why we set 800 millimeter, is just for you to be able to see the effect. You might actually not get this, so it's something we can even reduce to, let's say 200, citing as an example. So you could click run, and then you see it, because we've reduced it, it's going to take a longer time before these areas are actually flooded. So they will get flooded bit by bit. All right, so thank you. Now let's move to so that's the end of our demonstration. Now got into the question and answer session of the webinar. So now we would entertain questions.
Thank you so much, Mr. Olarotimi. Honestly, I think I didn't even do justice to your portfolio, because this is very, very insightful. Very, very insightful. Thank you so much. Thank you so much. So now if you have any question, you can drop it on the chat box or you indicate by a show of hand. And also do well to know that when you're not speaking, please turn off your mic. Okay, so we have some questions here. Okay, the first person is asking, he said, please, what is the minimum land size suitable for these analysis?
Okay, thank you very much, Eugenia. So for this, there isn't actually a minimum to it. Like you could even do it for, let's say, a ward or even a community. It's not necessary it has to be a state, a local government. So there isn't a minimum land size to this. You can even do it for a street. It's as good as that.
Okay, thank you. I hope the question has been answered for whoever is asking this question. The next question. Thanks for the tutorial. I would like to know how I can calculate the volume of flood water for the various classes.
Okay. The volume of flood water. For this, as I rightly said, depending on the data set that you've actually brought in, for this particular is actually calculating based on the area size. So for you to do something like that, we would need data for let's say water discharge for the area, and then we can now incorporate this into, because the idea behind this, we can actually create a model from this as well. So we didn't incorporate that into this particular, but for us to be able to do that, if you add that particular data, you could do that. There are two options to it. You could do that when you intersect on the attribute table, or you could actually write a Python script behind this for you to be able to get your result.
All right, thank you, sir. So, Mr. Victor, I guess your question has been answered. So I can see Mr. Emeka John, your hands are up. So go on with your question.
Yes. Good afternoon. So my question is, I actually appreciate the tutorial and everything. It's really very, very insightful. My question is really about, the aspect where we had to assign some level of weightage to each of our parameters. And the presenter mentioned that we can, get those values maybe from like experts' opinion. But it turns out that most of these expert opinion can differ, based on those that are the experts. So if I get from different experts, it's going to be different from others. So I'm asking, is there like a recommended, weightage or that you can suggest? The idea behind this question is that, trying to see replicability. So if you do this for Macaulay and somebody else does it for the same Macaulay using different expert opinion weightage, we will not get the same results, right? So how can we, enforce uniformity or enforce replicability even in any other place? So that's.
All right, thank you, Mr. Emeka. For that particular question, it's actually a good question. So the idea behind this is this: there isn't like a uniform weight that you can assign. Like it's, as I said, it's based on expert. Because the idea behind this is this: how I see things, as you rightly know, might be a bit different from how you see it. The class I would decide, or how the rate at which I feel digital elevation model as DEM would have an influence on flood, you might not see it the same way. So the how do I want to put it? Like, it's at the expert discretion level. There isn't actually a universal weight that you can assign or you would assign. But the only thing I can tell you is, for most part, when it's an expert opinion, it won't be the same, but it will be close. Just like as I mentioned earlier on, it's a general knowledge where everybody knows when you're reclassifying, areas with vegetation are actually less prone to flood as compared to where you have bare land or built up. So that's my answer to that.
Okay, thank you. Thank you very much.
Thank you so much, sir. Mr. Emeka, I hope your question was well answered.
Yes. Thank you.
All right, thank you. So the next question, please, what is the minimum land size suitable for this analysis?
So I think we've discussed this earlier. Okay, though I've opened up the chat. There isn't a minimum to it. You could even do it for a street. It's as good as that. You could do it for a street. As well, I'm seeing a question which is it possible to do a 3D using Sentinel-2 data? Yes, you can. So the idea behind this is this. It's now your ability to be able to see those buildings, and then you're able to digitize those buildings before you convert it to a 3D model. So that's the idea behind this. Yes, we could provide the recording after this webinar. The slides, all right, the slide, my own slide or our own, just to be clear. All right, still the slide, or I would make that available. Okay, we'll make that available. Leslie, you could reach out to us after the webinar. We could discuss further on that as well, the slide. Oh, thank you very much for appreciating our slide. But as I said, don't worry, I think we'll provide the tool. The recording soonest we'll provide the recording. So I think I would hand everything off to Eugenia to pick up from there. Think about that, the questions from the chat.
Okay, thank you so much, Mr. Arutimi. I can actually see somebody's hand. Ayobami, Mr. Ayobami. Please go ahead with your question.
Yes, good morning, still morning. Good morning, Mr. Salau. So, unfortunately, I joined while you were almost in the middle of the business. So, what I want to ask specifically is, which of the actual did you use in your presentation?
Mr. Ayobami, please come again. The network wasn't so good, so I didn't hear. Which of what?
Okay. Which of the ArcGIS tool did you use in your work, in the showcase you did?
Okay, so I used a lot of tools. Just to mention a few, extract to maps, slope, fill, flow direction, flow accumulation, the raster calculator, stream order, stream to feature, buffer, as well as weighted sum or weighted overlay. So those are the tools that I actually used for this.
All right, thank you. But I'm not sure you answered the question. But what I'm asking is, which of the ArcGIS tools, are all the tools you mentioned now ArcGIS tools?
Yes, they are all tools in the ArcGIS Pro. When you have ArcGIS Pro, you'll be able to access this through the geoprocessing toolbox. So these are all the tools that were used. Or are you talking about like the software that was actually used for the entire
You
webinar?
now connect the question rightly. Thank you.
Okay, all right. Thank you.
All right, thank you so much. I can see another hand. Mr. Moses, please go ahead with your question.
Good morning. Can you hear me?
Yes, we can hear you, sir. Good morning, sir.
Thank you so much for this presentation. It's really educating enough, especially for myself. I just want to ask, the rating that you gave each of those layers, did you apply a AHP criteria analysis? That's one, if that is what I actually to give the rating. And then again, this is outside of this webinar, but I'm having issues with ArcGIS Pro. Recently, I bought a system, Dell XPS 13. Initially, when I installed ArcGIS Pro, it was working fine. But a few days later, when I click on it, it will never open again. So I don't know what you could advise on that, if there is any solution to that kind of thing. Thank you.
Okay, thank you, Mr. Moses. So for this particular one, we did not use analytical hierarchical process for it. We did not. As I rightly mentioned, expert opinion is what we used for this, but analytical hierarchy process is something that could actually be applied to this as well, so as to get the right weight to it. But for this, we did not use that. So as regards the ArcGIS Pro, please, you can reach out to us after the webinar, and then we'll look for a way to solve that.
Okay. Thank you so much.
All right, thank you.
Thank you.
All right, thank you so very much for your questions, and I hope every question was well answered. I also want to say that we have trainings available, so details will be sent to your emails, so you'd know how important the training is and how it helps you in your analysis and every other thing you would want to do. Yeah, so thank you so very much for your time, Mr. Jibril. I really want to appreciate you and commend you for your effort. Thank you so very much for your time. Thank you for the materials. Thank you for speaking. Thank you for the whole session. We're really grateful. Thank you also. Thank everybody for joining. Thank you so much. And we will look up for another session like this next month. So do have a wonderful day, and that is all from my end. Thank you so much.
All right, thank you, everyone. Thank you.